Is what we were doing yesterday. We were just talking about acute angles in right triangles. Okay? So we said something about this. This begins really easy. Literally with sine is opposite over hypotenuse. A lot of stuff. Sine of A is opposite over hypotenuse, 5 over 13. And we wrote down sine. We actually wrote down all 6 trig functions for angle A and all 6 trig functions for angle B. And then we talked about how they were related. One of the biggest pieces is right there. Because angle A and angle B are related. How are they related? They're complementary angles right there.
Oh, yeah.
Okay? And all complementary angles add to be 90. Okay? So we said, well, could we rearrange that and solve for B equals?
Yes.
Could we have solved for A equals?
Yes.
Yes, you could have.
And that's only for right triangles, right?
Only for right triangles. Right now, for a good long time, we are only going to talk about right triangles for a while. Eventually that will change, but not for quite a while. Okay? So we said, after we made this connection, all of these things over here, what did we call sine and cosine? When they equaled sine A equaled cosine B, they were co-functions. The cousins, yes. All the COs. Okay? And cosine A equaled sine B. Tangent and cotangent. What else?
Cosecant.
Secant and cosecant are all co-functions. They're co-functions, and they're complementary. They're all the COs. We wrote underline COs. A lot.
Instead of
Like
complementary, we could say cosecant and secant. Or
What?
cotangent and secant.
Alright. So you should have all of this in your notes. Okay, we're going to add more to it.
Okay, I'm gonna write on the different page. I grabbed the wrong one.
Alright, are we good to move on? So we said yesterday, all of this, co-functions. And so instead of writing sine A equals cosine B, where we solve B equals 90 minus A, that's what we plugged in for all of these. So if you were to add the A and the B together, the two angles, they're always going to equal 90 degrees. They're always going to be complementary. Then we work some examples. Sine 15, really, if we wrote it in terms of its co-function, is really equal to cosine 75. And then we plugged those in our calculator, and we tried it out.
Yes.
Okay? And then we said tangent 72.5 degrees really equals cotangent 17.5 because we did 90 minus 72.5. And that's where we get that number. Okay? All of those are in a box on page 51. It's a lovely green box. Generally, those green boxes are good. On page 51, they're all there. Yes, ma'am. Is Landry going to blow in the whistle? You were holding your mouth like you were blowing. It looked like something was there like you were blowing.
I'm sorry, that was funny.
Oh God. I should be acting.
Can I give you another problem? Okay.
Oh, yes.
So a new problem.
Sure thing. That's
Okay.
playing with
So you're not writing anything. If you were here yesterday, I'm assuming you get this.
Yes.
Alright, so what happens if I give you secant 2 theta plus 30 equals cosecant of theta, let's say plus 56. Find theta. No. What is theta?
An answer with numbers.
Find one solution for theta then. I was on page 51, so I'm close to there. Would y'all do a check? Yes? Okay. Did you understand what I just put up there?
I knew you were.
Sort of yes, but no. I got like
So, sine A equals cosine B, or sine A equals cosine 90 minus A. Okay? What do you know about the angles A and B, or A and 90 minus A? Okay.
Wow. So like this, let's no, you have to watch the reference. Sine A, cosine. Yeah, sine A, cosine. Answer. I get it.
So, what are you telling me? That that's going to be equal up there?
No, I have no idea how to solve that.
What are A and B?
the tangent.
The tables.
I mean, that's potatoes.
I'll just take what they said because that's not right either.
Yeah.
It's the same.
Oh my goodness. It's whatever's in the parentheses.
What are
Oh, 30 is A.
A and B? What are A and B?
Equal to 90.
Oh.
How are A and B related to each other?
Hey, that's what I did.
90.
They're equal to 90. Okay? So one thing you have to know is, I gave you a secant and a cosecant. How are secant and cosecant related to each other? No. Secant and cosecant are
Stop over there.
co-functions.
Yeah, I knew that. I just don't know how to solve it.
So, they are co-functions. What do you know about A and B?
They equal 90.
They equal 90.
Whoa.
I'm very good. I thought the
I mean, A plus B equals what? I probably made that too big.
90. So 3 theta plus.
Okay?
Wait, so you can just ignore the secant?
No, you can't.
No,
Because if I-
don't write it.
No, you do not write it. But they have to be co-functions.
Right.
If I gave you secant and tangent,
You don't have to
you
write
can't do it because they're not co-functions. You have to know they're co-functions to be able to do this. So then we're going to simplify, and you're going to get what?
Well, 3 theta plus A6 equals 90, and then you subtract A6 from both sides. So 3 theta equals 4. And then you divide 3 by both sides, and theta equals 4 thirds.
Whoa. That's just math. That's just algebra. Okay? The biggest piece is knowing how to set it up. I'm sorry, Lorenzo. I walked by and oh yeah, because my brain wasn't turned on either. My brain was not turned on. Because I go up, I'm like, no, they're not equal. Can they be equal? Does A equal B?
Nine.
Yes, you can.
Only
45.
one time does A equal B.
Yeah.
Do not think about that. Because they're still add together to equal
99.
90. Okay? Setting it up.
It's 90 plus 0. Oh. But that's not possible.
Can you have two right angles? Is that what you're telling me? No.
I was just thinking, oh my god.
Could you have,
Wait, so what you get, Jada?
you're done. It says find one solution for theta that makes this true. Did you find one solution?
Yes.
4/3. That's when Miss Evans makes up problems and I don't really pay attention to numbers.
Good job.
Okay? What if you have cotangent theta? That was kind of hard. Cotangent theta, I think it was -5. No, it was -8. I always forget degrees. Equals tangent 4 theta plus 13. Find one solution for theta that will make the equations true. Oh yeah.
Do
And a
those,
half
do
there.
those also
I don't get a half there. What are you talking about?
do those also equal 90?
I don't know. Are they co-functions? You have to know
Yeah,
they're related.
I know
Wait,
they're
why don't you get a half?
But do they
This
also
is what
equal
they
90?
work.
You gotta go. You don't have to teach.
Let your body go to work.
So what do y'all do?
This seven, do they equal 90 as well?
Are they co-functions? So A and B will always
Equal 90.
equal 90
How do you know it's A and B?
because they're co-functions.
How do you know that?
Lily, what'd you get?
Because tangent and cotangent are co-functions,
So if they're tan and they're reciprocal.
not reciprocal.
Oh, now I understand.
Not that's 4 theta. My thetas.
That equals.
So what are you doing?
I'm shooting. I just have no idea.
Theta minus 8
I got it.
plus.
I hope I'm right because it didn't have to in my head.
Right? This is how you set it up.
Yes.
Wow.
Oh, okay. Wait, what are you solving for?
Theta. It's an unknown. What value of theta? What solution? Give one solution for theta that would make this a true statement.
May I work on it?
Come on, Landry.
Go,
Would you like a pen?
Spread
No.
your wings.
I'm going fingers this day. I don't do the squiggle, I just do a line through.
That's fine.
Alright, cool, just letting you know. That's a 5, not an 8.
It was a fall. What the fall? That's what last one was.
17.
Alright, are you following what did Landry just do?
Yes.
He collected like terms. 5 theta plus 5 equals 90.
Oh, I got
It's all 5.
Okay,
Oh, what?
are we together? Is the correct answer 17?
Yes.
Yes.
Is that 85 divided by 5? Then yes. Mine was.
5 theta plus 5 over 5.
Wait, are you gonna give us another one?
Yeah, you should do another one. I really don't want to do another one.
But you do. Wait, why'd you put the square root?
Because he's being crazy.
The same as it, but not the same.
Alright. I know that I have almost no control, but when I let children come up here, I really feel like I have no control.
But hey, that was pretty good control. I answered the question.
But 8 people, however many people were sitting here, were not engaged with you. They were talking and laughing about other things.
Engaged.
Like 3 is fine.
Alright. Alright, what about trig values of special right triangles? I don't remember if it was you or if it was somebody else who's already talked to me about special right triangles. What do you know about special right triangles?
That's not a right triangle.
It is not. Thank you,
You have to
Landry.
draw the
The thing. What were you gonna say?
A dash line.
The dashed line. If this is an equilateral triangle, what do you know about it? It's Lily.
It's equal angular.
It's equal angular. What else do you know, Zach?
May I?
Landry.
That's right.
Hold on.
Okay, this is an equilateral triangle. What do you know about it? Lily said they were equal angular. Landry.
Split it down.
I don't want to split it down the middle. I just want to talk about an equilateral triangle.
All sides.
All sides are the same. All angles are the same. Can we be more specific about all the angles? Is every angle 60 degrees? Okay. Every triangle has equal one angle. Okay? So now, can you tell me, is this also an isosceles triangle?
Yes.
no.
2.
It has to be at least.
Is it also isosceles?
Yes.
Yes.
Yes, it is. It just says at least. So all the sides are the same. There was a theorem somewhere in geometry that talks about cutting isosceles in half. If we bisected an angle, then what happens to what does it do to the opposite side?
Bisect.
Ooh. It bisects it as well. More specifically, at a right angle. Okay. It's a perpendicular bisector. The angle bisector is also the perpendicular bisector. So if we take this and draw it straight down, now
That's like
that,
60, 90.
but I didn't want that then. I wanted just equilateral.
That's not bad.
Okay,
Okay, now.
so now, Landry,
Okay, so then the bottom side angle is split in 2. So if it was 4, then it would be 2 and 2. You got 2.
okay, so this side equals this side.
Yes, but that's not. I'm trying to get to a point. Can you draw 2 and 2 on each side?
Down here.
Yes. So all the sides equal 4. Now those 2 equal 2. And
So
in
can I
the
go ahead and do
middle-
this?
The middle is one of those sides on square root 2. The bottom side is on square root 2. That's square root 3.
Ooh, this was on one of my ACT.
Square root 3. It's 2 on the square root of 3.
So the height,
It's S, 2S, S on the square root of 3.
Equals half the base.
okay, what else have we not put in here?
Angles.
Angles.
Your box.
Do I need that's a right angle?
Yes.
That's a right angle. What about up here? Alright. So I'm gonna leave one of these. I'm gonna leave this triangle up here. Lily just told me another one. Okay, so can I write the one Lily told me?
Yes.
That's just the half If it's 30, 60, 90, what did you tell me those sides were? And can you tell me where they
The
belong?
hypotenuse is 2s.
Hypotenuse is 2s.
The short side is s. And the long side is s on the square root of 3.
Why?
Side.
Coach King taught you x, 2x, and x on the square root of 3. Why is it a square root of 3? How do you remember that?
Pythagorean theorem.
Pythagorean theorem, yes.
I just
But
remember.
it's a 36.
Yeah.
You were told me 2 earlier.
Yeah, I know. That's because the other one
Because-
was
Same
using.
as a Pythagorean triple.
100%.
Is
3,
that
4,
what
5.
those are? No.
Oh,
It's 3, 4, 5. It has to be whole numbers.
wait. I thought it was when they. Oh, wait, never mind.
Alright. I remember it's square root of 3 because it's 30, and then a 60, and then a 90. Okay. So I remember 30, 60, 90. 3, 6, 9 are all divisible by 3. So my square root will always be a square root of 3. That's what I remember. Alright, so now for you,
Oh, that's smart.
that's just what my brain
What
says.
is it again?
30,
Mhm.
60, or 90. 3, a 6, and a 9 are all divisible by what? 3. 3, 6, 9. So I always remember it's the square root of 3. 45, 45, 90. There's 2 that are the same, so it's the square root of 2. That's how my brain works. So now I need everybody to tell me what sine 30 degrees is. I need you to tell me what cosine 30 degrees is. Guess what? We're not stopping. Tangent 30 degrees. Not secant. I like cosecant first. Cosecant 30 degrees. Now I'm going straight down the line. What about secant 30 degrees? What about cotangent 30 degrees? Go. You have 2 different triangles. And when I want these, guess what? I want exact values. So plugging them in your calculator does not help you at all. Doesn't-
Oh.
What do you know
I
about
got
30
it.
degrees?
I got it.
Opposite over hypotenuse. Do you have 2 different triangles that you can look at 30 degrees? Yes.
I'm confused.
Sine 30. Look at 30 degrees.
Yes.
Opposite over hypotenuse.
Oh, we're looking at that one.
Either one. You can look at this one. What's opposite over hypotenuse?
So did it just be a bunch more loose?
It was the same thing. Why did you get up and go get a calculator? I don't need that. For what?
What page are we on?
Oh. I kind of get it, but not really. Oh, wait, that does make sense.
What do you know about sine? Opposite over hypotenuse. What do you know about cosine? Adjacent over hypotenuse. Tangent. Opposite over adjacent. Last 3, you're just flipping the first 3. It's not hard. So depends on which triangle you want to look at. If you like these numbers better than the letters, by all means use the number one. So sine 30 is what, Lorenzo?
Sine 30 is square root of 3 over 2.
Sine 30 is what?
Square root of 3.
Opposite over hypotenuse?
I did it.
Do you know SOHCAHTOA?
Yes.
Sine is opposite.
What could you use? Never mind.
What? That you have to reduce?
No.
What is sine 30?
1/2.
1/2. What is cosine 30? Adjacent over hypotenuse.
Square root of 3 over 2.
Why is nobody telling me 2 square root of 3 over 4? Why? Why in the world would they not tell me 2 square root of 3 over 4? Why? Are you going to leave a fraction as 2/4?
No, absolutely not.
Never, never, never. Are you going to leave this fraction as 2/4? Never, never, never. So they're just reducing before they tell me. Could I have used this one? Adjacent is s square root of 3 over 2s. What reduces? The s's. So you still get the square root of 3 over 2. I tried to tell you. Yes, ma'am. I will.
Good luck, bro. Thanks.
Hey, buddy.
Bye, Landry.
Is it you and Justin and
Alex and Andrew and Holden.
Holden? For
Andrew,
sale?
the president. Mr. President.
The one that
Wear a fedora.
Bye, Andrew.
Who's up?
Bye.
Bye, Landry. Thanks. See you
we're
tomorrow.
gonna answer all of these.
Bye, Landry.
And no,
Bye, Landry.
What we doing?
no. Do you have all these answers?
I have the tangent.
All right, what's tangent?
No, you see there. Is it the one that's greater than two?
I don't know. Is it? What did you do? Tangent 30 is what? Opposite over adjacent. So it's 2 divided. Opposite is 2. Adjacent is 2 square root of 3. Are you going to reduce before you rationalize? Please. I mean, you don't have to, but it makes it really nice. So what is it? So what? I think is what you said. So you get the square root of 3 over what? 3. Okay. All right, can you give me the next 3? What is cosecant 30? You're flipping sign, so it's simply 2. What about secant 30? So you got to flip and rationalize. What about cotangent? I look over here to this. And it's square root of 3 over 1. Or just square root of 3. Okay. Now, are you ready to answer some more questions? Do we have another angle up here?
Yes.
Would it be okay with you guys if I erase some of the extras? Can I just erase that? Do that as a 2. So what is sine 60 degrees? What is cosine 60 degrees? What is tangent 60 degrees? What is cosecant 60 degrees? What is secant 60
I can get
degrees?
it.
I know you can. You are equipped with everything you need to know. You have triangles. You even have, how are 30 and 60 related to each other?
They're co-functions.
They're complementary and their co-functions are,
Oh, reciprocals equal.
30 and 60 are complementary, so their co-functions are
The same.
equal, the same. So does sine 60, what does sine 60 equal as the co-function?
The square root of 3 over 2.
Which is
Cosine
That one right there.
30.
cosine 30. But look at your triangle, does it work? If I'm looking now, I need different colors. I need different triangle probably.
Look at this. Easy breezy.
Sine 60 is opposite over hypotenuse. So does it equal the square root of 3 over 2 when you're looking at a triangle?
What is tangent?
What's its
Square root of
co-function?
60.
Or tan 60 is opposite
Oh, is
over adjacent. Oh wait, I'm not on tangent. You are. What's cosine 60? Adjacent over hypotenuse. Is a half. That also sine 30. They're co-functions. Tan 60. Opposite over adjacent. 2 square root of 3 over 2. What's 2 square root of 3 over 2 when you reduce? Square root of 3. Is that also cotangent 30?
Yep.
Cosecant 60. I'm flipping sine 60. Or I see a cofunction. That's secant 60. Flipping cosine, or it's cotangent 60. Flipping tangent, or I see cofunction. We have the square root of 3 over 3. And now that Landry is left, I'm happy that he gave me this triangle, but this is not the triangle I would draw. Why would I not draw this triangle with a 2 and a 2 root square root of 3 and a 4? Is there a better one? An easier
Yeah.
one? No, not a different triangle, but a different 30, 60, 90. I almost like Lily's better. Other than variables. What's the nicest variable you can put in there for F?
Oh,
One.
2.
He put in 2.
1.
It's 1.
1, 2,
It's a 1, 2, square root of 3. Then I don't have to reduce. Ever. Is there something that 2 and 4 and 2 square root of 3 all reduce by? 2. Yes. So could I make a 30, 60, 90 triangle with a 1, a 2, and a square root of 3? This it's going to always be the same answers. Always. Even if I did 7, 14, and 7 square root of 3. Every bit of it will reduce.
Wait, so you could essentially memorize all of them?
You're going to have to.
Well, technically you don't have to.
Technically, all you need is a triangle. What you have to remember, are you listening? What you have to remember? Smallest angle, always opposite the shortest side. You remember that from geometry?
Yes.
Smallest angle, opposite the shortest side. Kind of. Not this right before that. Okay? Where's the largest angle?
Hypotenuse.
The hypotenuse, well, 90 degrees, but the hypotenuse has to be the longest. The square root of 3 is that in between 1 and 2. Yes, it's like 1.7 something. Okay? So they go in order. Okay? Biggest key when you're labeling this, because this triangle I will draw for you very few times, and then you're going to have to draw it for yourself. Okay? 1, square root of 3, 2. So there's going to come up a time, a lot from now on, that it's going to ask you about, well, what is tangent of 60 degrees? You're going to draw the triangle. Don't try to memorize what tan 60 is. Draw the triangle. It's square root of 3 over 1. Okay? What's cosine 30? It's a half.
Interruption. Teachers and students wanted to let you know before the day got away the results of the student council representative election. And so congratulate these winners. Thanks for everybody that was willing to put their name on the ballot. 9th grade class rep is Braden Bright.
vote for this man?
Yeah.
I voted for you.
Thanks, bro. All the
And myself.
See, that's the
That's
problem.
what happened.
Why did it take the girls 4 years to realize that all the boys are going to vote for one person and we're going to split up our votes and the boy's going to win every single year? That's what I was just trying to say yesterday. If all the girls picked one girl to vote for, we would have
Did all the girls pick a girl?
No, they pick different girls.
Yeah, we split
This
it up.
year?
Yes. Everyone voted. There were probably three votes for every girl. And then all the boys voted for McMurray.
That's just how you do it.
I know.
It's
a
not
lot.
I
What
know
I'm
that.
more amazed about than anything is Brady Bright is a brand new.
Yeah, that's what I was thinking.
He is a brand new.
And Abram.
No, okay, Abram.
All the guys
I
voted for
completely see Abram.
No, they
I
did that
didn't
as a
know.
joke.
What was it? Abby was like, hey,
That's that
yeah.
class.
And all the girls, all Miss Caperso's girls voted for him.
Yeah.
Plus all the guys.
Oh gosh.
I see Abram completely. Brady Bright.
Yeah.
Brand new, never been there. Okay, last but not least, what other type of triangle do we have?
Good job, Zach.
What is special about a 45, 45, 90?
Oh, these two are equal to each other.
These two are equal to each other, so can we say the legs?
Yes. Leg
Legs
one
are
and
equal.
leg two are equal, and the hypotenuse is a square root 2.
Okay, so
Yeah.
does it matter what number I put on the side length?
Nope. Not at all.
So what is the nicest, easiest thing to put?
One.
One square root of 2. So what is sine? All 6 trig functions of 45 degrees. Go. So you should have all 3 of these written down.
It's a degree of 36.
Okay, then you've got homework. Do it now or have homework.
I'm
I
trying.
don't have any room.
Oh, I do not believe.
I don't.
Cosine 45 degrees. Tangent 40. It's going to take you longer to write.
I'm good, they're the same.
Why are they the same, McMurray?
They equal 90.
They equal 90, meaning they are complementary. So cosine 45.
And tangent,
Yeah.
cosine 45 and sine 45.
So what are they?
I don't know.
One. They're one.
No, they're not. Not tangent is.
They're square root of 2 over 2.
I just wrote it there. What is tangent?
Would it not be square root of 2 over 1?
Tangent relate is on the hypotenuse.
It's just 1.
Opposite over adjacent, which is.
I know.
What about cotangent 45? Does it have to be the same thing? Ow.
Sorry.
Yes. But you
Secant and cosecant, do they have to be the same? What are they?
square root of 2. Yeah, you wrote the square root of 2 over 2.
Because 45 is 1 divided by the square root of 2.
Oh,
And you have to rationalize.
that's cool.
Alright, class is over. You may go. Sorry, Sydney.